10 Crackpot theories about space, the final frontier, a seemingly infinite region filled with so much wildness and weirdness that even the brightest human minds can hardly begin to understand it. Gazing up at the stars on a crisp, dark night, it's hard not to wonder about what lies beyond our simple earthbound existence. For better or worse, some people take that wondering and speak it aloud, breathing life into their hypotheses. And sometimes unfounded ideas, like a nasty virus, become contagious and spread all over the place, displacing actual science with crackpot theories that make just enough sense to be potentially dangerous. Not all crackpot theories about space are created equal. Some sound downright silly. Others are complex, or convoluted, enough that they sound like they could be true. Sit down and we'll spend the next 5 hours explaining just how it's possible that the moon landing was a hoax, complete with in-depth analyses of photographs and video, bookended by explanations of why the government would do such a thing in the first place. By the time we're done, all of it will sound very believable, right down to the soundstage diagrams drawn on a bar napkin. That's the essence of popular crackpot space theories. They're given life by a few believers and then disseminated to the masses. And suddenly there's a man on the moon, aliens on Mars, and deadly doomsday comets filled with giant flesh-eating termites headed straight towards New York City. So buckle up and prepare your critical thinking skills. Which of the following outlandish theories will make headlines and which ones are just for clowns? 10 Venus was a comet. Imagine our solar system as a pool table and the planets are billiard balls. They collide and smash and create new heavenly bodies in their wake. That's basically what author, scholar and psychiatrist Immanuel Velikovsky proposed in his 1950 bestseller, Worlds in Collision. In those pages, he asserted that about 3,500 years ago, a large body slammed into Jupiter and then ejected Venus in the form of a comet. Venus then sped around the solar system, buzzing by Earth in the process and causing biblical catastrophes, until morphing into a planet. Physicists and astronomers roundly rejected Velikovsky's theories, in large part because it violates the laws of physics. For example, his ideas were in direct conflict with Newton's law of motion, which deals with aspects of acceleration and velocity. Furthermore, the composition of Venus's atmosphere is far different than that of Jupiter, and there's no geologic evidence on Earth or anywhere else to support his claims. His book was panned immediately and nearly universally. Yet his ideas played upon biblical stories and ancient mythology in ways that made them appealing to certain people, and as such, he left an imprint upon popular culture that science hasn't yet totally erased. 9 Universal Splat. You've heard of the Big Bang Theory, which holds that the universe exploded from a single tiny point and is still expanding outwards, stretching and moving beyond its point of origin. But what if the Big Bang was actually preceded by a big splat? Take two universes, smack them together, and you have the beginnings of the so-called ekpyrotic, Greek for conflagration, scenario, brought to life in 2001 by several physicists. In this scenario, the universe is cyclical, periodically repeating similar events. Multidimensional universes smash into each other, starting universes anew, but without the inflation and expansion of the Big Bang. As with so many models, the ekpyrotic model relies on assumptions about mechanisms that make the universe work. But for most modern scientists, this model relies on far too many assumptions and subsequent complexities, Google ghost condensate if you dare, that render the whole model interesting but highly unlikely. The simplest explanations are often the most promising. And the measurements and theories behind the Big Bang are still the best understanding we have of our universe's genesis. 8 White holes. Nature exhibits its share of symmetry and mirroring. That's the thinking behind white holes, which are the theoretical opposite of black holes. Black holes, of course, are those weird space objects with a gravitational pull so powerful that even light can't escape its grasp once it passes a point of no return called the event horizon. In theory, the event horizon of a white hole would do the opposite. Instead of pulling everything, it would push everything away. Any matter near a white hole, in fact, would cause it to collapse. Because black holes do exist and form by the collapse of stars, matter is always present, meaning that a white hole probably can't be a reality. Black holes don't necessarily need an opposite. They may in fact just be a point in space that doesn't really have an other side. And for as weird as black holes are just by themselves, maybe that's a good thing. 7. The universe is a hologram. With all the chatter about virtual reality technology these days, it could be that our universe itself is the ultimate illusion. Perhaps our lives aren't truly three-dimensional, maybe we all live inside a 2D hologram. At Fermilab in Illinois, a group of scientists is conducting experiments to find out. The experiment involves aiming powerful laser beams arranged in an L-shaped configuration and called a holometer. If detectors in the system see variations in brightness of the laser beams, it could potentially be due to some sort of noise or interference. Ultimately, that could mean that the universe around us has limitations in terms of the information it can store. Just as a 2D TV signal can transmit only so much data, perhaps nature itself can only provide so much data, too. Maybe reality itself is, in a way, already virtual. So this one's not so crackpot after all. 6. Observing dark energy keeps it unstable. You've heard the old saying about how a watched pot never boils. Well, according to some theorists, peering too closely at the universe, or parts of it, at least, destroys it. Some people say that observing dark energy is akin to destabilizing our reality. Scientists currently think that matter, stuff like rocks and glass and water, makes up only about 4% of our universe. More than 26%, however, is dark matter. Source: NASA. You can't reach out and grab dark matter. You can't see it through binoculars. It's a type of mass that we're unable to see. We know it exists because of its gravitational effects. Another 70% is dark energy. Source: NASA. Scientists aren't sure what it is, but this unseen force throughout empty space seems to be propelling the accelerating expansion of the universe. And in one widely publicized research article, Professor Lawrence Krauss speculated that simply observing dark energy may have reduced the life expectancy of the universe. It's due to a quantum Zeno effect, a quirk of quantum mechanics which basically says that observing an object directly affects it. Source: Krauss and Dent. So by the simple act of observing dark energy, we may have messed with the inner quantum clockwork of the entire universe, possibly causing it to revert to some earlier form, and sending us into a strange, Star Trek-worthy oblivion. Actually, Krauss's article was exaggerated by the media, especially the parts about the universe ending. He immediately edited for clarification, but he didn't skewer his idea altogether. The quantum Zeno effect is very real. So if you set out to observe dark energy, for the sake of the universe, don't look too closely, just to be safe. 5. Black hole information paradox. Nothing, not even lickety-split light, can escape the sticky grasp of a black hole. And once something is sucked into a black hole, no one knows exactly what happens to it. Does it reappear on the other side in a nightmarish version of Walt Disney World? Or does it simply wink out of existence, so profoundly destroyed that it's as if it never existed? Physicist Stephen Hawking proposed that black holes really might simply obliterate entities, to the point that only the barest quantum mechanical traits, such as electrical charge and spin, are left behind. But there's a problem with that theory, namely that all of the established rules of the universe say that information can't be totally lost. It has to go somewhere, otherwise there's no real order to anything at all. Quantum mechanics, along with so many established principles of physics, would be shredded, leaving scientists bewildered at the most basic properties of reality. In the late 1990s, Hawking backed away from the idea that black holes completely destroy information. Instead, he speculated that perhaps information does remain, but in an altogether different form. So in the off chance you're ever caught in the grip of a black hole, take comfort in the fact that you'll not be lost forever to time. Perhaps you'll just be reconstituted as a slice of atomic pizza. 4. Earth's moon doesn't rotate. It's one of those shower thought moments that strikes novice astronomers from time to time. When you look up at the moon, it always looks the same. Why doesn't the moon spin? Actually, the moon does rotate, but it takes nearly an Earth month to do so. As it spins, it's also circling the Earth, and as it does, the same side of the moon faces our planet. This is called synchronous rotation, and it ensures that the man in the moon always has a good view of us. We don't always see a simple static view of the moon, though. During certain periods of its orbit, the moon is tilted just enough for us to see a sliver more of its surface. That amounts to just less than 10% of extra moon real estate, but it's a tantalizing glimpse of the dark side of the moon, which features massive numbers of craters from millions of years of bashing from space objects. 3 pulsars are alien beacons. For decades, researchers have observed signals from space in an effort to detect extraterrestrial communication. Somewhere buried in the far-off heavens, perhaps another form of life was desperately looking for cosmic cousins, maybe by using beams of electromagnetic radiation. There are some people who think pulsars may indicate a form of alien communication. These stars regularly emit electromagnetic radiation every few seconds, or fractions of a second, as they spin, sending pulses of energy through the universe. The regular pulsing is reminiscent of human-like communications. It's normally regular and patterned, though some occasionally experience brief glitches in their spin rate. So far, though, no signals have borne traits of complexity or structure that would give them meaning as language or messages. Maybe someday another civilization will send us a greeting card via the stars. If they do, hopefully we're advanced enough to understand their sentiments. Planet X will destroy our world somewhere in the darkness of space. A rogue planet, unencumbered by any orbit in a solar system, spins its way towards Earth. In the end, it will collide with our mother world and the end of times will be upon us all. It was nice knowing you. That's the premise of Planet X, a wandering planet on a collision course with Earth. Only Planet X isn't real. It was a concoction imagined by Nancy Leader, a Wisconsinite who launched an online discussion group in 1995. In the forum, she related stories about gray-colored aliens that implanted communication devices in her head for the purpose of using her to alert her species to imminent danger from Planet X. Planet X, she said, would pass so closely to Earth that it would disrupt all natural processes and destroy life as we know it. As hoaxes go, this one was largely fueled by dissemination power of the Internet. NASA indicates that if a planet was on target for Earth, we'd know about it at least a decade in advance, plenty of time to stock up on doomsday t-shirts and canned goods of all kinds. One ice baby. The most logical crackpot theories may make you pause and wonder. Others simply make you think their originators probably consumed too much beer on long winter nights. When it comes to the world ice theory, or Tyler, the latter seems most likely. Austrian mining engineer Hans Horbiger published a book on his world ice theory in 1913, with the help of astronomer Philip Foth. In it, the two claimed that ice was the foundation of the entire universe. The lengthy book blends elements of mythology with all sorts of pseudoscience. But in essence, the story goes like this: long ago a dead, water-logged star crashed into a giant, hot star, causing the smaller one to explode into water vapor, which eventually froze into blocks of ice strewn across the universe. It only gets more convoluted from there, but according to Horbiger, you should know that hailstorms are caused by meteors striking Earth's atmosphere. Science teachers commence cringing. Horbiger died in 1931, but it's unlikely he would have enjoyed the fact that the Third Reich appropriated his ideas as part of their campaign to rework modern science, which was too Jewish in their estimation. An ice-based cosmology spoke to Hitler as being more Nordic and Aryan than others, and thus perfect for advancing his crazed master race philosophies. Let Horbiger's legacy be a lesson to you: if you decide to concoct a wild theory about something, make sure it doesn't appeal to the dark side of humanity. Otherwise your crackpot space theory may blacken your name for centuries to come. Note: 10 crackpot theories about space. In the summer of 2007, I camped alone on a ledge near the Rio Grande River in New Mexico. A twinkle of light descended from the stars above me. Figuring I was just tired from driving all day, I ignored it. But then the pinprick twinkle descended to the space just above my tent, and to my astonishment, slowly circled my sight, hovering silently in the late-night air. Just as inexplicably, it sunk below the ledge, disappearing from my sight and leaving me forever wondering what it was that I saw. I'm fairly certain it was a fairy from the dark side of the moon. You can't prove me wrong. You weren't there. Let me draw you a picture. You'll come to see things as I do.